On June 29th, the most powerful machine humanity has ever built went quiet. Not because it failed, not because of viral claims about portals or alternate realities. The Large Hadron Collider was switched off on purpose for a planned 4-year upgrade. But here's what almost nobody was talking about. Before the shutdown, physicists were studying subtle hints that may not fit the standard model, the theory that has explained the fundamental building blocks of the universe for over 50 years. And then the machine capable of investigating those hints went silent. For decades, the standard model has been one of the greatest achievements in science. It describes the particles that make up matter and the forces that govern them with astonishing precision. Again and again, experiments have confirmed its predictions. But there's a problem. The standard model doesn't explain dark matter. It doesn't explain why gravity is so much weaker than the other forces. It doesn't explain why the universe contains more matter than antimatter. Physicists know it's incomplete. They've spent decades searching for the first unmistakable sign that something lies beyond it. In recent years, researchers at CERN's LHCb experiment have reported several intriguing results involving the way certain particles, called mesons, decay. According to the standard model, these decays should follow very precise patterns. Instead, some measurements appeared to show tiny deviations. Not dramatic, not definitive. Just enough to make physicists wonder whether they were seeing the first hints of entirely new physics, or simply statistical fluctuations that would disappear as more data became available. This is how scientific revolutions often begin. Not with certainty, with small inconsistencies that refuse to go away. If these hints are eventually confirmed, they could point toward new particles, previously unknown forces, or even help explain mysteries such as dark matter. Then came the scheduled shutdown. The Large Hadron Collider entered its planned long shutdown to undergo major upgrades that will allow it to operate at even higher performance when it returns. This wasn't unexpected. The shutdown had been planned for years, but the timing is fascinating. Just as physicists were collecting data that could reveal whether these anomalies were real, the world's most powerful particle collider paused operations. The questions remain. The answers must wait. At the same time, much of the internet was focused on claims that CERN had opened portals or somehow changed reality. Those stories spread quickly. But the real scientific mystery is arguably even more fascinating. Humanity has built a machine capable of recreating conditions that existed fractions of a second after the Big Bang. And within its data may be tiny clues that our best theory of reality is incomplete. Not because someone imagined it, because careful measurements suggest there may be something we still don't understand. Of course, science demands patience. These anomalies may eventually disappear as more precise measurements are made. That has happened before. Or they may become the first confirmed evidence of physics beyond the standard model, a discovery that could transform our understanding of the universe. When the upgraded Large Hadron Collider begins producing data again, scientists will continue searching for those answers. Until then, one of the biggest mysteries in modern physics remains unresolved. Perhaps the real question isn't whether CERN changed reality. Perhaps it's whether reality is more complex than our greatest theories have yet been able to describe. If that's true, the next breakthrough may not change reality at all. It may simply reveal that we never fully understood it in the first place. If you enjoy exploring the mysteries that challenge what we think we know, subscribe to Beyond What We Know. Because sometimes the biggest discoveries don't give us more answers. They give us better questions.